Hey, we're going to be covering Chapter 8.5, Add and Subtract Rational Expressions. This is slightly more complicated than our previous section, which dealt with multiplication and division of rational expressions, but we're still using the same general concepts that we applied to those. So first, let's talk about adding and subtracting with like denominators. So addition with like denominators, with variables, we could have a over c plus b over c. These share a c as their denominator, so we simply have a plus b over c. With numbers, this would be 3x over 5x squared, adding something that has the same denominator, so 5x squared, and we just have 3x squared plus 7 over 5x squared. Subtraction is much the same. We have a minus b over c. And then with numbers, 9x cubed over x plus 1 minus x squared over x plus 1, which just is 9x cubed minus x squared over x plus 1. So like denominators are pretty simple. We just change what the numerator is on top by adding or subtracting. Now, with unlike denominators, this would be something like a over c plus b over d, in which c and d are different and therefore unlike denominators. So we need to make them have like denominators by multiplying both sides by something that makes the bottom cd, so our least common multiple. We want to find that between c and d, and that will be cd. So we're multiplying the first term by d over d, and we're multiplying the second term by c over c, so that both terms have cd as their denominator. So we have ad over cd plus bc over cd. Therefore, we have ad plus bc over cd. Now, subtraction, again, is the same. We want to have cd on the denominator of both terms. Therefore, we have ad minus bc and over cd. So again, with unlike denominators, we want to, in the end, have a like denominator, and we will do that by multiplying both sides by something that creates the least common multiple. So in our first problem, we're told to add 7 over 9x squared to x over 3x squared plus 3x. So first, let's factor both of these. Well, really, we're just going to be factoring the second one. So 3x times x plus 1. Then we need to have we want to have as our least common multiple of these two terms, we want 9x squared and x times x plus 1. So in the end, we want to have 9x squared times x plus 1. We want this in both of our denominators to make them like denominators. So our second term, we will have plus something over 9x squared over x plus 1. So in order to get this denominator from both of our terms, we need to multiply our 7 over 9x squared by x plus 1. And we need to multiply our second term by 3x. So when we're going to our next step, we have 7x plus 7 and 3x squared. This will simplify to 3x squared plus 7x plus 7 over 9x squared times x plus 1. And it depends if the book will want you to have a more simplified version of the denominator, but I would just watch out for what the directions are telling you and what form our original example is in. Now, our second problem kind of has division problems within our main division problem. And it may seem daunting at first, but we're just going to be dividing by a like denominator once again. So we want to have, not dividing by a like denominator, but we're going to be multiplying so that we achieve a like denominator. So we're going to do this by canceling out these division problems. So we're going to multiply the entire thing by x times x plus 4 which will give us, so this will cancel out our x plus 4 on the top and this leftover x, so this x plus 4 will cancel out with this one and this x will go with the 5. So we have 5x over x plus 2 times x plus 4. Once again, you can see how this cancels out with our terms here. So we have x times x minus x plus 4 multiplying by 1 over x plus 4 and then multiplying by 2 over x. So in all, we have 5x over 3x plus 8.